Hello there. This is Sonia Han, the director with Skayl, a small business headquartered outside of Washington, D.C. in Westminster, Maryland, and presenting a poster today for the AMTC annual conference, Got Data Models? Are They Any Good? The work that went into this has been a collaborative effort with myself, Chris Alport, Gordon Hunt, and Dave Lombardi, who are all three co-founders of Skayl. We are a company that focuses on automating integration and integration solutions. So the reason that we're here today is with the increasing popularity of model-based system engineering, MBSE, data models are becoming more commonplace in software architecture and acquisition requirements. So whether you're developing data models to these requirements or you're assessing the goodness of these data models, how do you know what good is? If your ultimate goal is to model for reusability, scalability, ease of management, and making future integrations faster to field, how do you know when your data model is good enough? So essentially today, I plan to provide you with a framework that can help you to start answering those questions. We're seeing the need for a framework around which we can contextualize our conversations about data models. And the IDML, or Interface Documentation Maturity Level Framework, essentially is intended to help meet that need. So what we're looking for is something that helps us understand, meet, and evaluate software architecture and acquisition requirements, to qualify a model's value to an integration, something that can enable program benchmarking and evaluation. So for instance, we're here, we're at IDML level 3 right now. This is what's going to change in our program over the next few years. So by the end of year 1, we need to be here, and by the end of year 3, we need to be here, right? So we're progressing forward. Maybe we started at level 3, we need to get to a 4 by the end of this year, and eventually we need to get to a 6. So that kind of benchmarking. Also, we're looking for a framework to encourage discussion and knowledge share. So a good, for instance, is I was at a conference, an international NIST conference on smart cities in Washington, D.C., and a number of my coworkers were there, and we had sort of a divide and conquer conversation, who goes and speaks to which companies and which cohorts. And one of my coworkers, Dave, went to speak with a European-based open standards organization that had built a data model for smart city applications. So he had a lengthy conversation with them about their approach and their model, but he couldn't quite get a grasp on it in terms of practically where their model stood that they'd been working on. He asked to look at it, and they were happy to share with him, and they went through it together. And when our team met back up later, and we started to share information about who we'd spoken to and kind of the status of some of the different efforts going on, Dave started to describe the maturity level of their model. He started with a description of the model, but then he kind of stopped himself, and because he was really getting down into the weeds. And then he stopped himself and he said, "You know what? I looked at the model. Basically, it's at an IDML 3." And at that point, everybody in the group knew immediately the maturity of the content and the structure of the model, how it could be applied, and what its limitations were. So he conveyed in 3 words what had taken nearly an hour of discussion and model review to tell him. So that's just an example of how such a framework might be helpful. So why are we focusing on interface documentation? At a fundamental level, it's the documentation of interfaces that enable a system's interfaces to be managed, shared, understood, and extended. And specifically, it's the rigor and specificity of that documentation that can provide a solid litmus test for categorically identifying levels of interoperability in an integration. In fact, appropriately rigorous and specific interface documentation can enable the facilitation of automated integration and maintenance, which is a huge coup. IDMLs are essentially to data modeling what technology readiness levels are, to tech development. I'm sure a lot of you are familiar with that. And the capability maturity model, CMM, is to software development, MRL, manufacturing readiness levels for manufacturing. The IDML model was actually originally proposed, published, and presented by our group at the September 2018 U.S. Army Open Group FACE TIM Technical Interchange meeting. It is applicable. There are applications that can be made to FACE, but also to many other standards that we work with. So over the years, it's become much more challenging to differentiate best practices from the use of various tools and standards. A lot of conversations tend to center around, oh, this is the standard that we work to, and these are the tools, the data modeling tools that we use. But it's, there's just quite a difference between tools, standards, and best practices, data modeling, data architecture best practices. So one way to help distinguish best practices is with a qualitative framework based on interface documentation. If we consider an interface, it is the anticipated use and the anticipated extent of use of a given interface that drives the rigor and specificity of its interface documentation. Now, that's because at a fundamental level, it is the documentation of interfaces that enable an architecture's interfaces to be managed, understood, shared, and extended. Thus, interface documentation may be considered a litmus test for identifying integratability. Something to keep in mind here as you look at the IDML and you see this kind of ladder, this colored ladder graphic on the right-hand side of the screen here, is that as the strength of a chain is determined by its weakest link, the success of the communication between an interface and its consumer is dependent upon its lowest level of documentation. So in other words, and you might want to come back to this thought once you understand the IDML a little bit better, but in other words, basically it's the minimal rigor to which the interface must be documented is dependent upon the highest level of comprehension required. So as the number of integrators or the size or complexity of the organization increases, so does the required rigor and specificity of the interface documentation. And by identifying the specific IDML for a given set of interfaces, it's possible to assess the ability of that interface documentation to inform integration over the life cycle of the system. Now the model, as you see, is intended to be a continuum model. Distinct levels are not always clear. Now, of course, for human comprehension, it's helpful to be able to have some distinctions, so we've tried to do that, but keep in mind it is intended as a continuum model. And it is also based on an additive maturity concept, progressing towards today's more advanced best practices in interface documentation. So as levels increase, rigor and specificity of the documentation increases. Ergo, its usability, management, scalability, automatability also increases. You'll also see as we talk through these levels that in general from the early, what we're noting as the early maturity levels through the advanced maturity levels, you'll see a general shift from implicit to the explicit, and as well a shift from purely documenting syntax to integrating context and semantics in with that documentation of syntax as we move towards the more advanced levels. So let's kind of break it down a little bit and start talking about kind of the early maturity levels. Also keep in mind, it's important to keep in mind here that we're not talking about good and bad. We're talking about maturity and appropriateness to a program's requirements and its complexity, number of interfaces, etc. So IDML level 2 is going to be completely appropriate in some situations where an IDML 6 would be, way too big, much more than what's necessary, and would require more expense than what's necessary for a program that really only needs an IDML 2. So there's not good and bad here. This is a continuum of maturity based on program requirements. Okay, IDML levels 1 and 2. So essentially in these early maturity levels, they're most appropriate when the program is small, there's relatively little change or turnover, and it doesn't require external interfaces. The most basic forms of interface documentation are characterized by these early maturity levels, and essentially interface documentation is limited in its specification. It captures the content of the interfaces in a human understandable form. So at this level, although source code, for instance, which we talk about in IDML 1, is certainly machine readable, there's no machine readable syntax or semantic meaning. So the interface documentation is, in order to understand that, we need a human, right? So IDML level 1 is essentially source code. So one could say with source code, one person might say there is no overt interface documentation that exists. Or we could say that the source code provides the extent of the documentation. It's a pretty limited extent, but it does provide the extent of the documentation. Code explicitly specifies the algorithm, but only implicitly suggests syntax and semantics. I'm going to go through these early phases, early maturity levels fairly quickly because we're all very familiar with them. The code alone provides valuable information, but it's an incredibly incomplete picture, representation of that big picture. Now, IDML2, and of course we can add comments, we can add, there's some documentation that we can add to the source code, but again, it is only human understandable. And as we know, anybody who's done any programming, you can come back, a year later, even to your own code sometimes and have difficulty understanding it. It takes a little while to get back in the groove. So IDML level 2, that's where we're talking about interface control documents or interface definition documents, ICDs, IDDs. These are very familiar elements in systems engineering. They are, sure, there's electronic versions, there may be PDFs, etc. There may be an online version available, but generally what ends up happening is that people end up printing these out. And a lot of times they'll put them in these huge binders. Folks who, as they work with the interfaces, they start making margin notes, things get changed, there are photocopies, they dog-ear pages, they put sticky notes to add more content or context to the ICDs or IDDs. Essentially, it's limited by the fact that it requires a knowledgeable user to read, interpret, and implement aligned code structures and type manipulation routines that are in alignment with the documentation. So these ICDs and IDDs are best used in conjunction with institutional knowledge. So let's take a look at the mid-maturity. So we're looking at IDMLs essentially 3 through 5. These mid-levels are most appropriate when complexity and scope increase and the interface management becomes more challenging. It may become necessary to record revisions, updates, and to trace changes, right? In the ICD and IDD, we can have multiple documents, but we're not really tracing our changes and tracing our modifications and as the program scales up or major changes are made. So users have felt the pain of a paper document-based architecture at this point, and they realize the need for something more rigorous. This level is characterized by the introduction of syntax in addition to content, and has the interface documentation now has the capacity to be machine readable. In fact, the syntax may be reused and shared among other systems. Particularly, this is useful when moving beyond a controlled set or when communication with external entities becomes necessary. So IDML3 is the electronic data definition, and it does add the rigor of syntax. It also provides rudimentary reusability. For example, classes and nodes may be shared, reused, limiting the duplication of effort. Electronic data definitions can be used to generate data type manipulation software, including source code. I want to note that. But essentially, they must still be accompanied by, or may actually be, an ICD or an IDD type document in order to provide the additional information necessary to actually implement it. Now, when we get to IDML4, we consider that the interface-centric model. Sometimes they've called the message model. And in many organizations, this is the level where we start talking about data models, right? Where we really start saying, oh, I want a data model. And this is where a lot of organizations start with their data models. It's essentially where we promote our messages into entities and derive our model based on that. So I'm going to use an analogy that we've used a number of times when talking to other organizations for data models and messages, and we call that the grocery store analogy. So the IDML4 grocery store is essentially designed around recipes, right? So the store is the model, and the recipes I'm going to talk about are the messages. So let's think about a grocery store that is designed around recipes. So if I want to make a classic chili recipe, okay, I go into the store and I go straight to the classic chili aisle. So there is an aisle specific to my recipe. In that aisle, I find the ground beef I want, the chili powder, canned beans, canned tomatoes, oregano, exactly what I need to make my recipe for classic chili. There's nothing less and nothing more located in that aisle. That's great. It's quick, it's easy. I can take my recipe, I immediately know what needs to be in my aisle, I can organize my aisle that way. Voila, right? But what happens if I need to change my recipe, if I want to change it, and I want to use basil instead of oregano? Well, my grocery store is just running around recipes. So I'm going to need a new aisle. Each aisle is for a different recipe. I'm going to need a new aisle for classic chili with basil. So I've got my classic chili, which is the one with oregano, and I've got my classic chili with basil aisle. But what if I want to use fresh tomatoes instead of canned? Well, that means I'm going to have to create another aisle, a classic chili with fresh tomato aisle. So you can see that over time we end up with a huge grocery store or model, and it can be very difficult to manage because it's very, very large. In addition, if let's say there's a recall on maybe the ground beef, we now have to go back into all those aisles with all those recipes that contain ground beef. I had to go back into all those aisles and make sure we swap out the ground beef in every one. And if I don't, there can be a problem, right? So if I want a brand new recipe, some completely different, I want my pineapple upside down cake, I need to create a new aisle. So essentially in this IDML4 grocery store, the IDML4 model, although messages can be reused, changes to a message require a change to the model. And the more complex the program is, or the more often there's a change, the harder it is to maintain the model, the harder it is to avoid errors like missing a recalled ground beef. So what happens in IDML5? This is an entity model with direct projections. So instead, in this model, content is organized in context, similar to the way our grocery stores are organized, right? The grocery store is now reorganized based on context. So there's an aisle for fresh produce, for meats, for spices. And what it does is it allows for reuse of not only a recipe, but also for the ingredients. When we change or add a new recipe, the grocery store layout isn't affected. The model layout, the model architecture is not affected. To prepare the recipe, we go directly to the aisles and gather the ingredients. We know where to find each ingredient quickly and efficiently. So again, this kind of model allows for not only basic model reusability, but basic model reusability across message sets utilizing the same building blocks. Now, we start to get, to an even greater level of maturity once that's required. And this is most appropriate, these advanced maturity levels are most appropriate when programs require the ability to manage more high complexity integrations. And it's characterized by the addition of containment and other relationships which provide context to existing content and syntax. The models become, in effect, become also more rigorous, testable, and fully reusable. It also begins to allow for the potential of automated integration. This is when we're talking about semantic architecture solutions. And essentially with this added rigor, robustness, and tested standards and testing, standards begin to emerge that provide the ability to leverage new and interesting ways to characterize semantically unambiguous data. So this is where we start to get into some really cool stuff. So an IDML6 is an entity model with containment. This is where entities reflect a real-world analog. It introduces semantic context. It's the containment that builds the context of the attribute. So the message attribute projecting from their attributes through composed entities. So we identify, it's kind of like identifying a grocery store and then entering that store and then going specifically to the aisles needed for specific ingredients. This process provides context, the name, location of where we purchased ingredients for, say, a recall, right? Let's say in a real-life scenario here with air vehicles, let's say we request a fuel tank's fuel level. That kind of a request provides little to no context or meaning. However, in a model that enables it, we can request the fuel level of specific fuel tank on a specific jet in a specific fleet. This is through a model with containment. So this provides additional context and helps us understand the meaning of the message. We can go even a little further. Within IDML 7, this is an entity model with relationships, not just containment. Not only are we able to trace messages through their containment, but we can also now trace them through other related contexts. So, for instance, a message may be interested in a video product generated by a specific camera on a specific air vehicle. A video product is not contained or composed into a specific camera, but rather the video product has a relationship with that camera through the generation of the file. In this way, the message could receive the context of the containment of a specific camera in the specific air vehicle, and also the context of the relationship between the specific camera and the video product. So that's a very quick overview of our early, mid, and advanced maturity levels of the IDML framework. I want to go over just a few takeaways with you here. And just as a quick overview, so I said in the beginning that what I was going to do today was I was going to try to provide you with a framework that would help you start answering the questions about goodness of a data model, right? And I hope that we've done that. I think that the IDML is a good framework to start those kinds of to have those kinds of conversations, and you take away from it that basically the more rigorous and specific interface documentation it can make automated integration possible, as kind of the more maturity that we have in those interface documentation, it becomes more machine understandable, and the relationships in the data model become more contextualized. As a program's or interface requirements change, it may be necessary to further specify the interface documentation requiring a higher IDML that may be necessary. The nature of data architecture and interface documentation specifically necessitates that this kind of a framework be based on a continuum. However, the goal is to provide a consistent context for the discussion, development, and evaluation of interface documentation. So we feel that this framework is appropriate for that. Something else to keep in mind is that interface documentation that is appropriately rigorous and specific enables the facilitation of that automated integration and maintenance that I was mentioning before. So the subject of much of Skayl's current work is formalizing and quantifying the normal forms of the more complex IDMLs against the data model. So if you're interested in more information on this, on the IDML framework in general, on automated integration, quantification against data models, you can check out our IDML white paper that we have written. That is at skayl.com/whitepapers. We also have a podcast episode on this topic that is available at skayl.com/podcasts. You can email us at inquiries@skayl.com, or if you're joining us today via the AMTC conference, you can chat with our president and co-founder, Chris Alport, through the virtual poster chat feature. So feel free to do that. Thank you, and I hope that this has been helpful. Have a great day.